from our system of equations to actually doing the operations with the matrices themselves. That looks better. All right, so a matrix. We usually represent a matrix with a capital letter. We talked about that before. We can also write it as the elements A sub ij with brackets around it. So both of these would be matrix A. And remember, without the brackets, A sub ij is one element. Of matrix A. And I is the row and J is the column. Two matrices are equal only if they're both the same size and each corresponding element is equal. So they both have to be the same size, 2 by 2, 3 by 5, something like that. And each element in the same place has to be equal, every single one. To add matrices or subtract A plus or minus B, they need to be the same size, and we add or subtract corresponding elements. So for example, if we had two matrices, let's see, 2, -5, 4, 3, plus 8, -9, 1, -3. We could subtract as well. We're going to add corresponding elements. So 2 plus 8, we get 10. -5 plus -9, -14. 4 plus 1 is 5. And 3 minus 3 is 0. So those two matrices are the same size. And we add the corresponding elements. And the two matrices would be equal if only if every element in the corresponding place were exactly the same. All right, so now we know about addition and subtraction. There is one kind of multiplication that we can do. Scalar multiplication. And scalars with matrices are just like scalars when we talked about vectors. Scalar just means a real number. So C is a real number. So C times A just means multiply every element by C. So 2 times A is 2. You multiply every element in A by 2. -5 times A is multiply every element in A by -5. So we can think of negative A is the same as -1 times A. So we multiply every element by negative 1. So that's what negative a means. One other piece of information. The zero matrix. The way we write the zero matrix is like this. It means every element is 0. And keep in mind that the zero matrix does not equal the number 0. The number 0 is one number. The zero matrix is a matrix full of zeros. And I'm going to say for what we've talked about before, our usual rules for arithmetic hold. So we can move things around in our equations. We can group them. We can put parentheses and multiply, distribute when we multiply by a scalar. All those usual rules hold. So with these rules that we have so far with addition, subtraction, scalar multiplication, we can actually do some matrix algebra. So for example, let's say that A is the matrix 2, -1, 4, 3, and B is the matrix -3, -6, 5, 1, and X is a matrix. We want to solve A minus 2x equals B. So we have a nice matrix equation that involves matrices. And X is our unknown matrix. Well, because our usual rules of arithmetic hold, I can solve this equation just as if we were dealing with numbers here. So I'm just going to get X by itself. So I'm going to add 2x to both sides, subtract b. 2x equals a minus b. And x is going to be 1/2 a minus b. Well, now I can write that out. That's 1/2 of the matrix a minus b, 2 minus -3, which is 5. -1 minus -6, so another 5. 4 minus 5, 1. 3 minus 1 is 2. It would be fine to leave your answer written like that. We could also divide everything by 2. So my matrix X is the matrix 5/2, 5/2, -1/2, 1. And that would be the solution to that equation. So it's kind of like solving 4 equations at once. All right, so we good so far? So we need one other kind of matrix operation. We've talked about addition, subtraction, and multiplying the matrix by a number. We need to know how to multiply matrices together. So what I'm going to do, we'll talk about matrix multiplication. do some examples. I will show you how to do these operations in your calculator. And then I want to give you a preview about where we're going with these matrix operations. All right. So our matrix multiplication. To test if it's even possible. The way we're defining matrix multiplication is only possible in certain circumstances. A times B. We need to know the dimensions of matrix A. So let's say A is M by N and B is N by P. These two numbers have to be equal. So the number of columns in A has to equal the number of rows in B. This M by P is the size of the result. So if we multiply these two matrices together, we'll get an M by P matrix. But we have to check to see if these two numbers are the same. The number of columns in A is equal to the number of rows in B. And what we want to think about, we multiply the rows of A by the columns of B. So I want to go through an example, a couple of examples of doing this, and then we'll talk about how we do it in our calculator. The way our standards are written, what the standards say is we need to be able to multiply anything below 3 by 3, below a 3 by 3 by hand. So a 3 by 3 and above, we can use our technology. All right. So let's say we want to, let's say A is -1, 0, 6, 2. And B is 8, -2, 7, 1, 0, 3. And we want to find, and the way that these questions will be asked is find, if possible, A times B. Well, how big is A? That's a 2 by 2, this one. 2 by 3. So we check, those are equal. That's good. That means it is possible. And my answer is going to be 2 by 3. So I'm going to write out all the pieces explicitly here so we see exactly how this works. You don't always have to do it this way, but I want to show this example. All right. So we're going to multiply the rows of A by the columns of B. So the number in the first row, first column, is -1. And I'm going to change this one number here. I wanted this to be -5 and this to be a +2. Wait, no. +5, -2. There we go. All right, so the first row, first column, -1 times 5 plus 0 times 1. -1 times 5, first row times the first column. -1 times 5 plus 0 times 1. First row, second column. -1 times -2 plus 0 times 0. First row, third column. -1 times 7 plus 0 times 3. Now we're going to do the second row, first column. 6 times 5 plus 2 times 1. Second row, second column. 6 times negative 2 plus 2 times 0. Second row, third column. 6 times 7 plus 2 times 3. So I'm multiplying the rows by the columns. That's going to be my result. It's 2 by 3. So then I'm going to do this arithmetic. So here I get a negative 5. Here I get a positive 2. Here I get a negative 7. Here I get a 32. Here I get a negative 12. And here I get a 42 plus 6. Which one? Yeah. No, plus 2 times 0. Yes?
So could we just skip having to multiply and just add it in our head?
Yes.
Okay.
I just wanted to show the process explicitly so we see exactly where all the numbers are coming from. So that would be A times B. And my result is 2 by 3. All right, I want to do another one. We'll do a 2 by 2 this time. So let's say we want to do 2, negative 5, 9, 7. And we want to multiply that by 3, negative 1, 3, 6. All right, let's check. This is a 2 by 2, and this is a 2 by 2. Those are equal, and my result is going to be a 2 by 2. So if you get anything other than a 2 by 2 out, you know you've done something wrong. So the way that I usually do this is like Aiden said, just kind of do it in your head. First row, first column, 2 times 3 is 6, minus 15. 2 times 3 is 6, negative 5, negative 9. First row, second column, negative 2, minus 30, minus 32. Second row, first column, 27 plus 21, 48. Second row, second column, negative 9 plus 42, 33. And that would be my result. In general, A times B does not equal B times A. Order matters. So you can't just set up your multiplication any old way. The order of multiplication matters. All right, let's take a look at how to do some of these operations in our calculator. right. So in your calculator, the first thing you need to do is tell your calculator. You need to tell your calculator about the matrix. So your matrix menu is here above the x to the minus 1 button. So I'm going to say second matrix. And it has a big list of matrices here. First thing I'm going to do is edit a matrix. So I'm going to go over to edit.
Oh, I did hear what you said, start off.
Can you open start again, please?
Yeah.
Me too.
Second matrix. Matrix is at the x to the minus 1 button. Second matrix. We're going to edit this matrix. And I'm going to, so go to edit, enter. I'm going to make it a 3 by 3. So you have to tell the calculator what size the matrix is. And for this one, I'm just going to put all the same numbers in it. So I'm going to put 5s in every place, just to make it easy. All right, so there's my matrix A. Now I'm going to do a matrix B. So I'm going to do second matrix, and I'm going to go over to edit. And I'm going to go down to matrix B and edit that one. I'll make that one a 3 by 3 also. And I'll put 3s in each of those. And now to do some operations. I can do, going to go to second matrix, and here I'm at A, just going to hit enter, plus second matrix, go down to B, hit enter, and I get a matrix full of 8s. Yeah. You don't. If it's there, you just leave it there. It won't mess anything up. I could do 3 times B minus 4 times A. Just type it in just like you were typing in numbers, and that gives me a matrix full of negative 11s. I could do A times B. A times B. And I get a matrix full of 45s. And here, if I did B times A, I would get the same thing because they're all full of the same numbers.
Yeah, wait, why is it 45?
Because you're adding 5 times 3 plus 5 times 3 plus 5 times 3 for
yeah,
each,
right, okay.
each element. We could do something like 2 times B times A. And I get that. So we can type those in just like you type in numbers. So some of your homework problems ask you to do these operations. All right. A preview of where we're going. So what we're going to do, it's not a bad idea. So here's my system of equations. We're going to, instead of turning this into an augmented matrix, we're going to turn this into a matrix equation. So 2, 3, 4, 3, 9, negative 5, 5, negative 3, 5, times the matrix x, y, z equals the matrix 5, 0, 9. So this is a 3 by 3, right? This is a 3 by 1. Those are the same. My answer should be a 3 by 1. That's a 3 by 1. What we're going to do is call this matrix A, this matrix X, and this matrix B. So A times X equals B. Because if I did this multiplication, I would get that system of equations. If we were solving this using algebra, what would we do? Oops. Divide by A. Well, we don't have matrix division, but what we're going to do is the dividing is the inverse operation of multiplication. So what we're going to do is multiply both sides by the inverse of A. And we have this nice property that A inverse times A is the identity matrix, which is just like the number 1. And we get X equals A inverse times B. So what we're going to do is write this matrix equation. We're going to find the inverse of matrix A and multiply that times matrix B, and that will give us our matrix that has our X, our Y, and our Z as our answers in there. So we need one other piece of information here, the identity matrix. The identity matrix, we write it as I as a capital I, and I'm going to write sub n. It's a square matrix, n by n. N by n. It has ones on the diagonal and zeros everywhere else. So for example, a 2 by 2 identity matrix is a matrix 1, 0, 0, 1. 3 by 3 identity matrix 1, 0, 0, 0, 1, 0, 0, 0, 1. And this acts like the number 1 for matrices. So I, the identity matrix times any matrix, is the same as the matrix times the identity matrix, is just the matrix itself. So it's like multiplying a number or anything by 1. All right, questions? So our homework today is just doing operations, addition, subtraction, some multiplication, solving some matrix equations, like the examples we did. All right. So we need 2 pieces of information before we can actually solve equations. We need to find the determinant of a matrix, and then we need to know how to find the inverse. We use the determinant to find the inverse.